In this lecture, we'll talk about the difference between continuous and discrete data. Before we start looking at the details, you can think of it at a high level like this. If the data can have an infinite number of possible values, then it's continuous. And if it can only have a finite or limited number of possible values, then it's discrete. Okay, let's start talking about continuous data. One way we can identify continuous data is if we can calculate it using a function. An example of this is the distance we've traveled in a car or a rocket ship or whatever. Now, we know we can calculate it with a function because there's a well-known function, rate times time equal distance, but rate can have an infinite number of possibilities and time can have an infinite number of possibilities. So distance can also have an infinite number of possible values based on the rate and time that we use. And so because in general, if we calculate something with a function, we could enter an infinite number of values for each of the terms in the function, we end up with an infinite number of possible results for calculating that function. Another way to think about continuous data is pick 2 points, and if there are an infinite number of possibilities between those 2 points, then you've got continuous data. Some examples here. Let's say the length of a piece of wood. If I say, give me a piece of wood between 1 and 2 feet long, there's actually an infinite number of lengths of pieces of wood you could give me. So you could give me 1.5 feet or 1.25 feet or 1.125 of a foot, but we can keep doing that forever. We can do 1.16, we can do 1.32, and so on. So there are an infinite number of possible lengths of a piece of wood between two lengths, between 1 foot and 2 feet. Another example is real numbers. Real numbers are always continuous data because if you have an imaginary number line and you say how many numbers are there between 0 and 1, the answer is there are an infinite number of numbers. Any number you give me, I can cut in half, and now I've got another number, and I can just do that forever. So those are examples of continuous data. Discrete data, the values are either known or limited, so there are only a certain number or certain specific values that the data can have. Some examples here are the days of the week. Right? There are only 7 days of the week, Monday through Sunday. So we can't have any, Monday and a half or Monday, Tuesday or anything like that. There are specific values and only those values for days of the week. Another example is blood type. So there are 4 different blood types, A, B, AB, and O, and that's it. Those are the only kinds. Now, there are other sort of modifiers for blood type, like positive and negative and so on, but the core blood types, there are 4 and only 4 of them. The final example on this slide is colors from a list. Not colors in general. Colors are from light, the wavelengths of light, and light is most definitely continuous. There are an infinite number of possible light frequencies, so color in general is a continuous piece of data, but color from a list is actually not. So let's talk about color some more. Let's say you're picking a color from a color picker, and I have some examples here. So is this continuous or discrete? The answer is it's discrete. So for the color picker on the left, we can only pick one of those hexagons. And while there are a lot of hexagons, there are a limited and set number of hexagons in that color picker. So even though color from light frequency is continuous, color when we pick it from a color picker is discrete because there's only a specific set of values that those colors could be. What about if we represent color using RGB values, red, green, and blue? So the typical thing that you will see in Photoshop or Paint.net, or pick your favorite paint program, is red has a value from 0 to 255. And green has a value from 0 to 255, and so does blue. What that means is we actually have a discrete set of colors that we can possibly have. It's a big set. It's 2 to the 24th, so it's just over 16 million different colors, which is pretty good, but it is a limited number of precise colors that we can represent using 8 bits, 256 possible values for red, green, and blue. And we use 8 bits for red, green, and blue, and regularly for one more component called alpha, which is actually opacity. So the opposite of transparency is opacity. So if alpha is 255, it's totally opaque, and if alpha is 0, it's totally transparent. When we combine all those things together, we use 32 bits to represent colors. Most human beings can't distinguish more than 16 million different colors just because of the way our eyes are biologically formed. So using extra bits to get more colors doesn't help if those colors are for humans. Okay, now it's time for you to do a little thought exercise to try to determine whether particular pieces of data are continuous or discrete. Here they are: the TV channels that you have available to you, the elements on the periodic table, the time of day, the day of the week, the temperature, shoe sizes, speed, and direction. So you should now pause the video and try to decide which of those are continuous and which of those are discrete. Okay, let's talk about the results. I've color-coded the results with red for continuous and blue for discrete, but because I recognize that colorblind people may not be able to distinguish between those colors, we'll talk about it as well. So the continuous data in this list include time of day, because there are an infinite number of time hacks between two particular times. For example, we could measure to the millisecond or the microsecond, or we could keep dividing by 1,000 to get more and more digits after the decimal point, and we can do that infinitely. So time of day is a continuous piece of data. We may not be able to measure it continuously. We can't have an infinitely precise clock, but it is still continuous. The same is true of temperature. We can have an infinite number of temperatures between 20 and 30 degrees, and even though we can't measure them necessarily based on whether we have mercury in a glass vial or we have a digital thermometer, we're still going to reach a limit of precision in measurement, but the underlying value, the actual temperature, is continuous. The same is true of speed. There's an infinite number of speeds between 0 and 100 miles an hour. And with direction. If we think of direction as expressed as an angle, there are an infinite number of angles between 0 and 360 degrees. Because we can always say, give me one more decimal point, give me one more decimal point, and that never ends. So that is continuous data. The discrete data in our list is the TV channels that you have available to you, the elements on the periodic table, the day of the week, as we discussed previously, and shoe size. So even though there are a large number of shoe sizes, particularly in Europe, but not in the US. In the US, we have, a set number, and there are more shoe sizes in Europe. So, but still, there's a limit, right? You can get a 42 or a 42 and a half and a 43, but you can't get a 42 and a quarter. Unless you have custom-made bespoke shoes, and most of us don't do that. So the standard shoe sizes are also discrete. So you could reasonably ask at this point, why do we care? And the reason we care is because knowing if our data is continuous or discrete tells us whether mean and standard deviation are going to be useful to us. So mean and standard deviation always work on continuous data. They always make sense. It's reasonable to use them on continuous data. Sometimes mean and standard deviation works on discrete data. We used mean and standard deviation when we were talking about shoe sizes, and it still gave us a sense for both the central tendency of the shoe sizes in a particular data set, and the spread of the shape of the distribution, if you will, from standard deviation. We could maybe use mean on something like days of the week if we encoded the days of the week, Monday is 1 and Tuesday is 2 and so on. If we were trying to figure out, for example, the central tendency of when do people take a long lunch? So I might take a long lunch on Saturday and you might take a long lunch on Tuesday, but if we gathered some data, we could maybe average all that data together and say, oh, it looks like most people are taking a long lunch on Friday because, it's the last day of work for many people and we don't want to be there anymore, the weekend's coming and so on. So sometimes it makes sense, based on a very precise question we're trying to answer, we can, in fact, encode our discrete data and do some math for mean and standard deviation. There are other times when it doesn't make any sense at all. Right? If we're talking about the TV channels, you really don't care to say, well, I watched an hour on this channel, an hour on this channel, and an hour on this channel, so what is the average channel I watched? That usually doesn't really make sense. We could push it towards a particular question, as is common, right? We could say, well, do you usually watch the major networks, which are usually near the early part of the channel spectrum, or do you watch the more obscure channels later in the channel spectrum? And the average might help us with that, but that's a stretch. It's also the case that when we talk about elements in the periodic table, if we talk about the different elements that are in Earth's atmosphere and the percentages that they are, averaging those things together to say, oh, the average element is argon or something, that doesn't make any sense, right? So it's discrete data that we're talking about, so mean and standard deviation don't really help us. I will also say, by the way, we explored using count for data analysis, and we found count to be useful when we were talking about a variety of different things, and count is usually applicable to both continuous and discrete data. To recap, in this lesson, we learned the difference between continuous and discrete data, and we learned that we care about that difference because mean and standard deviation always work on continuous data, but if our data is discrete data, we have to think a little harder or maybe reformulate either the data or our question to make it reasonable to use mean and standard deviation on that discrete data.